Hey everybody, this is Larry. This is me going Q2 of the weekly contest for 33 maximum and minimum sums of and most size K subsequences. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I was a bit slower on this one, honestly, because if you watched the live portion, my internet went down a little bit. I had to reboot my router and stuff like this. But honestly, I still took longer than I should. I think this is just about it's mathematical for me. I just wasn't sure that I'm not double counting, which for this problem is just means that I'm weaker at combinatorics and that I need to work that out a little bit more and practice that a little bit more. But yeah, but the idea here is that okay, for each number we just want to say if this number is in the subsequence, what is how many times is this number in a subsequence in which it is the max sum? So that's easy to say, right? I mean, yeah, okay, Larry, you could do that by doing it n squared, and it's too big for you to do n squared. Well, what happens next? Well, the idea here is actually kind of I would like to say it is kind of beautiful. Sorry, I'm just loading up my drawing utensils. Are they called utensils? I don't know, but the idea is that okay, yeah, this is subsequence, right? Because this is subsequence, this enables you to do sorting because the order doesn't matter. You just want a bunch of numbers. You want it less than k numbers, and you just want to get the answer, right? And then the idea here is then, let's say you have sorting. Then now what does that give us? This gives us a structure in which, when you're now doing a current number, you know that every number that we've done before, is smaller or equal to this number. And in this one, I think I also got a little bit confused with this problem, just confusing myself. I think this one, actually, the problem statement is fine, but I confused myself because I think I was trying to find distinct subsequence, if that makes sense, but where like all the elements are unique or something. Well, not unique, but just like if they're 3 3s and the other sequence have 3 3s, you want to separate them. But no, you actually want to count them independently, which when I realized that, I was able to get it, but it was too slow. In any case, oops. The idea here is that, okay, let's say, let's just not do unique numbers for now, right? For now, let's do, let's just all keep it all unique is what I meant to say. For now, so let's say you have 1, 2, 3, 4, the numbers don't actually matter, as you will see, going left to right. And let's say k is, you go to, 2, right? Then now, okay, well, we're going from left to right. We know that the first number is 1. How many numbers are there where 1 is the max element? Well, we just sum it up. Okay, including, and the thing is that, okay, first we're forced to choose this number because we're saying by definition 1 is part of the answer, right? So that means that, yeah, so in this case it's actually pretty annoying or pretty trivial. There's 0 other numbers, so there are 0 other ways, but one way is technically actually 0 choose 0 is 1, so that's fine. And there's one way to do this number. What about 2? Well, now that you have 2, and let me change colors real quick. Now that you have 2, then how many ways are there, right? Well, you have to choose, you have to force the 2, and of course to the left, we know that there's one number that is 2 or smaller, so we have one number. We want to do a choice thing. I forget notation, is it like, or the drawing? So you want to do choice of one other number. We want to choose 0 of them. What does that mean? That means that we have a subsequence of length 1, the 2, right? Plus the choice of 1, choose 1. That's just, we have one other number. We want to choose one number, right? From those one number. Of course, that's only 1. So this is 1, I think. This is 1. So then there are 2 ways in which 2 is part of the max number. And of course, in this case, you have to multiply by the value, so there are 2 sequences times 2, right? Okay, let's do 3. 3 is the same thing, honestly. The value is 3, of course, and then now you have to choose you have to choose one other number Did I mess this? Yeah, we have to choose one other number out of two other numbers, right? So just to choose one plus this, right? And this is going to be 2, this is going to be 2. So we have 4 sequences or subsequences, and each of them we have to times it by 3. So it's 0 to 12. Okay, I think you get the idea here, and the recurrence and the pattern, right? And the idea here, of course, is that k can only be up to 100. So therefore, you can loop all this, right? You can loop all these and then just times it by the number, and you'll be fine, right? Pretty straightforward so far, kind of, maybe not, I don't know, right? And then now the one more clink, right, is that let's say we have a duplicate number. So actually, let's replace this 4 with a 3. Well, what happens? Well, it doesn't matter whether we have this 3 or not, because all the previous, we're not double counting, because when we pass this 3, it does not consider things to the right. So whether this 3 is in here or not, it doesn't change the answer where this 3 is in the answer. And that's the only observation you need to know, which means that this is going to be C. You have 3 other numbers. You have to choose one of them or 0 of them. So that's 3 plus 3, which is 6, and also times 3 again. And that's it. I mean, that's it in idea. In terms of implementation, there is some stuff that you have to do with mod, and as a result with dynamic programming. This is if you remember your Pascal's triangle, your combinatorics, your choice, Google these things, and that's basically how you come up with this. I mean, honestly, I didn't really come up with it. It's just that this is something that, you've seen it enough times. This is how you calculate choice, right? And the reason why we have to calculate it out in DP is, of course, of this mod. We have to calculate the mod, right? So we have to mod it, and that's why we have to write it out. And basically, dp of ij is just to be clear, dp of ij is equal to I items, choose j of them, right? And that's it. Basically, first, oh yeah, there's the min-max part, but it turns out that you could separate them out. They don't really, it doesn't really matter, because, yeah, if you think about it, it really doesn't matter, because if you think about the min and the max, they don't really interact with each other, as long as you it's just about each number's contribution, right? So each number's contribution is linear because it's just sum, and each number contributes to the min plus the max, and because they are addition and they don't infect each other, you can kind of write it out that way, right? You can think of it as like if you write out all the sums, right? Did I take out? Okay, just want to make sure that I took out the graphic. But you took out all the sum, right? You write out all the addition. You write out all the addition, then you can just rejiggle the addition, and as a result, we put all the min on one side, put all the max on the other, and then you calculate them differently. So that's how you that's the proof for them being independent, if you will. So here you just have, I think this is this is the max side because we sorted by max, so that's the thing that is a little bit unclear. But yeah, going from left to right, you're going to sort it, and then reverse. Actually, it's the same logic, except for when you reverse the array and you go from left to right, now you're going from large numbers to small numbers. So then the invariant there is that when you're at number x, every number that you parsed before is x or greater, which means that x is now the current min item. So that's the idea. That's really it. Yeah. And so what's the complexity here, right? Well, it's going to be dominated by this n log n. And I guess max k times max n. But that you only do it once, at least the way that I did it here. So that should be okay. And that's it. That is all I have for this one. Let me know what you think. Thanks for watching. And yeah. You could watch me solve it live, including when the internet went down. But mainly, I was still slow on this one, but because I was trying to do all the proofs and I kind of, like I said, misunderstood parts of it. But you can watch all of that now. Forgetting variable names 1113. All right, let's go. Okay. Whew. I don't know. I'm just so worried about silly mistakes these days. It should take another minute. Anyway, mod. Let's do a mod. All right. nums k, return the sum of the maximum, minimum, or subsequences of nums at most k elements. What is n? N is big, so it's not that. It's not a brute force for some reason. At most k elements. So what is k? K could be, oh, only 100 actually. So that means that n and k is the index. Is that fast enough? 10 to the 7 is 10 million. Kind of awkward actually. This is a Q2. Do you get it already? No. Okay, well. It's not tricky Q2. Like, I just woke up from a nap. Okay. Subsequence. The sum of the maximum or subsequence with M. Okay, so one element is going to be just or 1, 2. Okay, let's do them separately. Maximum element of all subsequence. So then that means that for each number, why is the 100 important then? We have to, so that means that for each number we have to figure out. Yeah, okay. So the max and the min independently. People always solve Q3, so maybe that's the easy one, easier one anyway. Okay, subsequent, so sort. And then, okay. So then now, I see, maybe. Is it though? No, it's just 100. I don't know why 100's important. We have 4 I in range of. Okay, so then that means that we want to choose k. So just n choose k. N minus 1 chooses k minus 1. Where do we double count? We definitely double count. How do we do it then? Okay, I mean this is fine. I think we're fine, but we just have to be precise. So we want to fix this is but the tie breaking one is the tricky part. How do I deal with tie breaking? How do I deal with tie breaking? Then okay, so for each I we do a k loop. That's fine. We want to okay, so that means that I mean we have to do it with DP, right? Because otherwise this is stupid. I mean I'm stupid, but math is hard. But it's not impossibly hard. Now we focus. Okay, max. Okay, so you do a scan. Let me n choose. No. Okay, that's why. Because it's n minus. No, because they're all distinct, even though it repeats. They don't have to be distinct, Larry. You don't. It's not a. So that means this is n minus one. Okay, so that means that's times. Oh, not n minus one. I minus one. Well, you have a k. So for choosing in range from 0 to k minus 1, because we chose 1, and we have, okay. I mean, I know that we need to write it in a way such that we're not doing stupid operations, but for now, okay, so we choose from I minus 1 elements, we choose C minus 1 elements. Yep, that's fine. And this is min of I minus 1, no, just I, and cannot go up to k. We want it to be k minus 1, so also fine. Something like that. K has to be non-negative. What is k? I think n choose k, so C has to be non-negative. Of course, we want that's fine. That's fair. 3 0 1. That's not right. Well, that's only the max. Is it true that this is the? Would it be right for max? Max is going to be. No, 3 is definitely not right. For 3, we want C to be k other ones. What is wrong here? Because we're only doing max, which is true. Okay, 2 3 1 2. This is 1. It's only one case. No, this should be 1. So this is minimum of I. So this is 2, and k is 2. So this should work for 1 other items, but 0 other items should work too. So that's what I'm missing. So 0. So 1. No. This is. I think I messed up something wrong here. This should be I plus 1 is the total number of items. Okay, is this right? 3. Maybe not. C should be 1 other items. No. Should be this. I think I don't need C minus 1. I think I'm just being dumb. N must be a non-negative number. No, it's I plus 1 minus 1. Because if index is 0, you have 0 other numbers. Okay. 14, is that right? 3, 3, 3. That's, maybe that's right actually for the maximum portion. 1, 2, what's that? 6 plus 6. Okay, 14 is right for the maximum. Okay. We have to rewrite this because this will time out for big enough numbers, I think. But we're okay. We're making progress. Oh well, we don't have to reset it. I think we're good. I think this gives us 24. Okay. So the math we got right, 24, 22, 12. We just have to figure out the programming part, which is the combinatoric part. I goes up to n, so okay. How does this go again? C is k, right? K plus 1. Right, so dp0001, and then how does combinatorics work again? It's like yeah, okay, fine. No, I keep on using K. Okay, so then it is just dpij is equal to pi minus 1, j minus 1 plus dp of I minus 1 j, right? Something like that. And then if dpij is greater than equal to mod dpij. I'm always worried about timing and stuff, but maybe this is okay. Okay, maybe not that okay though. 00 is going to be running out of issues. Okay, and choose one is whatever, so and choose one, okay, fine. And choose one. And choose one, whatever, whoops. Something like that. Okay, so now we're good. Are we good? Good. Let's try a big number. Or whatever. Let's just say 1 times 5, right? I think that's the max case actually. Let's actually do k is equal to 100 as well. Right? Is that too slow? Only 3 cases and it's already too slow. That's not good actually. I was gonna submit it. I don't know if this is a Python thing or a Java thing. Well, like yeah, like can I do this fast in Java? This is too slow though. I don't know if this is just me. Either way though, let's think about ways to improve this while we can. Yeah, at this point it should have timed out. So I think servers may be having issues. Let's refresh another page. Yep, server seems to be down. It's not refreshed. It should be immediate, but it's not. So that's not great. But let's. Can we optimize this before? N times k is so silly. 10 to the 7 is so tight. Can I do better than n times k? I mean, this we should probably. I mean, I hate to do this, but I really do. Actually, 102. But I don't even know if this helps that much because there's still a loop inside, right? But it doesn't hurt. Unknown error. All right, let's try again. Okay, this refreshed, so. But now it's not. Now I'm having issues. So let's see what you're saying in Discord. Huh? Maybe my internet's having issue. That would be very wonky because I. Huh? My internet is having issues actually. Why? What are you doing, internets? Okay, that's not great, but at least it's not Leetcode. Let me unconnect, disconnect. Can't even English. That's okay though. That means that we can. Okay. Alright, well, I feel like I haven't had an internet issue in a while, so this is not good. And now we refreshed out of that problem, so I don't even know what Q3 is. All right, let's see. Okay, so it's back. So it is just me. Okay. That's fine. Internet issues. Okay, so does this actually take time out? Okay, my internet's still good. 3 seconds for the worst case. I don't know. Is it worth a YOLO? Yeah, let's do it. I don't know if Leetcode is being silly or not, but n times k is like, I wouldn't be surprised if it times out, but I would be very sad if I have to rewrite this. Okay, so we're done here. Yeah, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, this explanation, everything in between. Keep it constructive. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.